Hello everyone, my name is Pravin. Till now you have already studied about vectors. Now let's talk about advanced containers like set and map. Presentation. Set and map. Firstly, we'll talk about set. Set is a container which stores unique values. Uh, and the special property of set in C++ is it stores all the values in sorted order. The value cannot be modified once it is added to the set, though you can delete that value and insert another value, which in turn will just mean you are replacing the value. You can do that in if you want to replace the value in the set. We can initialize set as set int for empty set of int, set string for empty set of strings, set vector int. It initializes an empty set of vector subintegers. Like if I do an example for this in code, just firstly we'll initialize a set int is now putting values into the set. Like if I insert this comes in the function. Like these are the functions in set, like set s dot insert, s dot erase, s dot count, s dot clear, s dot size. Let's see all this in code. I have initialized a set at empty set of integers. Inserting some values into the set. Now let's see uh, uh, what is the value of set now. Firstly, see what is present in the set in this case. Don't confuse this debug statement. I have just defined it above. Like this debug statement just prints the value of the set. Let's see. Firstly, the set is empty. Then I inserted as 1 into the set. Let's see what's the value of set then. What's in the set then? 1 went into the set. Let's insert 2 into the set. Now let's insert 0 into the set. Yes. Now this is a special property which we have studied here. Like it keeps the elements in the sorted order, like 0 and 1. We have inserted 1 before, but the value comes at 0 and 1 because it is in sorted order. Now let's insert 1 again into the set. So let's see what is in the set now. Same. This is because set stores unique values. Now if I want to insert 2 into the set, and if I want to replace 1 in the set, that is I want 2 in the set and not 1, then we have to do two things for this. That is, firstly erase that element from the set, erase 2 from the set. Now insert 2 into the set, erase 1 from the set and insert 2 into the set, like this. Debugging. 0 to removed 1 from the set, inserted 2 into the set. Now let's do some more operations. Like let's insert. I inserted. I have shown erase. Now let's see about count. Count tells the frequency of x in the set s, that is number of times x is present in the set. However, we know that a set keeps unique values, therefore it is either 0 or 1, because if the element x is present in the set, then it will return 1, else it will return 0. Let's see. Let's insert some numbers into the set. Like I inserted 10 numbers into the set. Now let's see the count of let's see the count in like dash printing. Let's not count of let's see count of 4. 1. As dot count is count of 4 is 1. Now let's see the count of the number which is not present in the set. Like as dot count of 11. 11 not present in the set, so count is 0. Now let's see clear. Clear just clears all the elements from the set, initially the set contains these 10 values. Now if we clear the set, then let's see the value of set is, and the value of set is now set becomes empty because we have deleted all the elements from the set. Now let's see the size of the set. Size of the set is number of elements present in the set. Debug, absolute. Size of the set is 10. If I remove some elements from the set like s dot is, it is 5. Now let's print see out. I just copy it from here. 9 because I removed 5 from the set. Now if I remove the same element twice, nothing will happen because that element is not present in the set. Just will do nothing. Like if I debug here, and if I debug here, if the value is not present in the set, then it will not erase because it is not present. Simple. Debug this. Like I have deleted 5 from the set, so set becomes this. I have again deleted 5 from the set, nothing changes. Yeah. Okay. And this operations like s0 s1 doesn't work in set. This is because set this is some advanced topic. The implementation is somewhat advanced. Like the set is implemented in trees, and in trees there is no concept of indexing. Therefore you cannot access elements like s0 s1. You have to access the elements from starting. Like if I'll show like in arrays are stored like in state manner. Like if you want to access the 1 2 3 4 like if you want to access this element, then you will do s2. But sets are not stored in this way. Sets are stored in red black tree. You don't have to know this red black tree because it is just implementation, and if you want to access some element in this tree, you have to begin with the iterator. Like a pointer is given, that pointer points to the memory location of the first element. Like the elements are stored like this: first element, second, third. So it is pointed to first element, and if we do plus plus operation, then the pointer comes to this, then it comes to this. We'll study this in next like next topic, I guess. Yeah, function set iterator. Yeah, this is only that set iterator. Like if you want to, like I have inserted some elements into the set. Now I want to access that element. Like if I want to access fourth element in the set, then I can't do something like this. This will give an error. Yeah. See the error is 4. No match for operator because this operator is not present in the set. If you want to access the fourth element in the set, then you have to do something like this. Like auto is just anything. Like we can do int also. Let's do int only for simplicity. Int iterator is equals to s dot begin. This is the first value in the set, first element that is present in the set. S dot begin. Yeah, we have to do because it is a memory address. Like we have to like this. Now this star it is the value that is stored at the memory address. This is the memory address of s dot begin, and if you want to get the value that is stored at this memory address, then we have to put star in front of this star it. Like if I print this like if I print this value will Give simply 1, the first value that is present in the set. The first value that is present in the set. Now if I'll do IT plus plus, IT plus plus, the pointer will go to the next value. That is, now I'll do cout cout2, second value is present in the set. I have removed set root. This is set. The first value in the set is 1, second value 2. If you want to access seventh value in the set, you have to apply something like this. You can apply loop I this auto iterator int is 1 equal to you want to get the seventh value, right? 7th I plus plus, and I will do iterator plus plus. Now I will get the seventh value star ID. Okay, 8. Yeah, and the value will be 8 because the iterator was pointing at the first element in the beginning, like 1. Then I had done 7 times, so 2, 3, 4, 5, 6, 7, 8. 8th number. So the value given is 8. Now we can access the elements from starting as well as behind. Like we can put end here. So this will be this last value. The value will be printed. Let's comment this and print last value. If I want to do first value from here, then I'll start from IT minus minus. And one thing to remember is that this is the pointer to the last pointer to the next element from the last element. Next from the last element, like IT minus minus. Let's see. At 4, because first it will come to 10, then 9, 8, 7, 6, 5, 4. Fourth value, star IT. Okay, the iterators. Now you must have studied iterator in vector also. In vectors you can do something like IT plus 3 or IT plus 2, but in set you cannot do something like this. This is because I have shown in OneNote that sets are not stored in single line manner. That is, sets are not stored like this. That is, you can just do plus 2 or plus 3 and access this element. Sets are stored in this way, in tree manner, in tree fashion. Like seems like I have not explained enough of this. Sets are stored like this, in tree way, something like this. So for accessing the element, you can s dot begin is this, then the iterator goes to this, then the iterator goes to this, then the iterator goes to this. It works like this. So you can't just directly do plus 3 and expect it to be pointing at the third element. You have to apply a loop and go to that element. Now function is set. This is interesting topic. Okay, I have put 10 elements into the set. First is s dot find x. This returns the index. Iterator simply means index at which it is present. That is iterator at which that element is present. Like I'll show in this here. S dot find. If I have to find the fourth element, I have to show it in here, I guess. No. Yeah, I have to take the value of this. Okay, so this thing returns the iterator at which the fourth element is present. Like the set is this, and if we find fourth, it gives the iterator that is present at fourth. That is this. The index you can assume like index. it gives the index. IT is the index at which this number 4 is present, and if I do star IT, that is the value that is present at that index, that is 4. Star IT is 4. Now if I let's consider if I want to find 11, then it will give nothing because that is not present in the set. Like s 11 like 11 is not present in the set, therefore it gives s dot end, and the element that is present at s dot end is 10. So if you print that value, it gives it is 10 only. Now these two are important, like s dot lower and s dot upper. S dot lower bound gives the iterator to the first element which is greater than or equal to, like if I'll do 4 here, then it will give, the iterator will give to the first element which is greater or equal, this only. So lower bound 4, because the first element which is equal to, you will understand this more by this, if I'll give iterator to 11, the first element which is greater than or equal to, no such value is present, so it will give s dot end again, s dot end last value. Upper bound is similar, just gives the value greater than x and not equal to. Then s dot erase, erases the element which is present at this IT place, the element, like if I delete s dot erase and IT, and if I s dot erase, like if I want to delete the 4 from this 4, find 4 from the set and I erase the 4, so the 4th is erased. Now this so the 4 is deleted. It erases the element present at this iterator position. Now let's talk about, before going into math, let's do a simple question in set. I have taken a question. Yeah. Okay. Make them odd. This is the question. This question came in some division 2 contest. Division. Okay. There are I'll just implement this so that you will have a better understanding in sets. There are n positive integers present in the array. For one move, you can choose any even value c and divide by 2 all elements that equal c. Divide by 2 all elements that equal c. For example, so different values are present with same values. You need to find the minimum values for transferring a to an array of only odd integers. Each element shouldn't be divisible by 2. Okay. For example, if a is this and you choose a is transformed into this, c is 6, okay, 3 and 3, and we have to transform this complete array into odd. Transform this complete array into odd. Okay. You need to find the minimum and the minimum number of moves for transforming this array. Okay, let's see this 46. I have to convert this array into all odd elements. So let's firstly sort the array, then you'll be able to see something. 36, 20, 40, 26, 20, 40, 40. Okay. If we divide this element by 2, then the both elements, is there one step? If we divide, okay, in one move, after it move, in one move, okay. You can divide all these elements in one move. So if you remove 140 from the set, then also it will not matter, I guess. Yeah, it will not matter because the division will show and they can all combine together. Yeah, just put that into the set. So this was like intuition behind why using a set. So if we firstly taking the input, okay. I take everything in vector only. into the integer. Now what I have to do, I have to, using iterator, I have to go from the largest element, divide that element. Okay, I'll define a set of initializing the set. Yes. Now inserting that AI into the set. Okay, now let's see what can find this one. Yeah, 1 3. Okay, now I have to do something like go to the last element, divide by 2, go to the last one by 2. Okay, then I'll take one pointer, okay, equals to last element, that's okay. And I'll go from the last element to the front till all are okay. I have to divide, I have to make the array as an array of only odd entries. Okay, so we just have to insert even elements in the set, right? If ai 2 is even element 0, then only insert. Okay, uh, then 40, and now I'll divide this and count. Okay, answer count is 0 and count is 0 automatically. So now I'll do from last index till this is not empty, till set is not empty, while s dot size is not equal to 0. Okay, while s dot size is not equal to 0, I'll remove the largest element from this set. Okay, uh, take that element into our consideration. So and some number, a temporary variable temp is equals to last element, that is it star ego. And what was it? It was the last. Okay, so define this here only by defining it into star it. The value it, and now this will have the last one, and I'll remove that value from the array. Iterator, last value is removed from the iterator 40, and now I'll insert divide by 2 and insert that. So m divide equal to 2 and insert this value into the set, like s dot insert. If this value is even, then only I'll insert. Yeah. If 10 or 2 is even, so I'll insert this into the set. Insert. Now number of times this loop is working, that is the answer. So count as this and say out. Right. This set is not, while set is not equal to, while set is not 0, when the size is not 0, why this went into an infinite loop. Still this process. Inserting that again, 40 20 20 10 10 5 odd, then only I'll insert. Let's see what is happening to set. 620 640. What? this is not 0. Take the last. Hey, I forgot to do minus minus. Like it is pointing to the last to the second. Yeah. Sorry. I forgot to do IT minus minus because the iterator at the end points to next element from this. Like mentioned here. So s dot end set iterations is like here s dot end points to the non-existent element after the last element. So I have to do s dot minus minus id dot minus minus. So it is pointed to the last element now, and I'll just print the count 410 40 410 40. So just submitting this, removing the debug statements here, here. I think this is fine. This will give an accepted button, I guess. Yeah, accepted. Now let's do map.